Good morning, madam. I'm Naavind Balan. My metric card number is 211291019. So today I would like to explain about lab for AC voltage controller. So this is my course that I'm taking for this SAM is EMK21603 Power Electronics. Okay, today I will explain about the experiment for AC voltage controller. The name I already mentioned above just now, and then my metric card number, and then the course code. Okay, in the AC voltage controller. So today I need to achieve for the objective of this project of this lab is to study and analyze the concept of a single phase full wave AC controller with a resistive load using PSIM simulate software. So these are the circuit maybe just now already built. Okay, for this one. Okay, so these are the circuits I will be able to do to calculate the voltage, amperes, and then the voltage. Okay, this before I'm explaining about this table, so they are having a firing angle around 0, 45, 90, 135, and 175. So these are the value that I need to convert it to do the lab, and then I will get the output. So the P in, power input, VRMS, power factor, and then the VRMS, V out, IRMS, I out, and then the power out. So this one I will base on the graph below. Okay. So this is a circuit I built. So this is my name, and then the power lab. Okay, then this is then my name. Okay, from here I will explain. I'm using AC sine wave to supply a nice waveform of sine, and then I was using that SCR. So the SCR name is under EC 3103D1 for the diode SCR. Not the diode, it's called as SCR because it has a gate. So if the gate is will supply some voltage, then only the gate will open, and then the resistor. So this is the input, and then the current will flow around 3.5 ampere. This is for the positive, and then this is for the negative cycle. And then input times with the output, we will get that over here, the value. And then this is the power. So for the power in the circuit, it shows 0 to 1.2 kilowatt. So at times with the V out and then the current. So the formula, because power equals to P equals to V over I. Then this is my output, the same value as 350 volt. Okay, these are the time. Later I will explain. Because of this time period, the waveform will be a bit different. So for this waveform, this one is for the 0 firing angle, and then this one is for the 45 firing angle. So the value will be like this: 2.5 milli and 12.5 milli. So this is my name, as just now mentioned. For this one, the supply sine wave will flow for the positive cycle first to the resistor, and then for the negative it will flow over this side bottom on the U2 to get the negative waveform. So this is the input as now as normal, and then this one is for the current flow. If the current flow is over here, the flow, when the tri this got any supply, then only it will be open. So it will be normal at the first, and then once the supply from the SCR source, So it will try to turn on, and then the supply will be shows as this. And then after that it will close, it will be normal back. And then after the got some supply on the SCR's gate, and then the gate will be open, and then it will go under the bottom side for the negative side, and then it will be back to the positive side, wait for the supply gate to open, and then the value. Same goes for out input output. Then the power is before the firing angles, it will be the zero. After once the firing angle is triggered, it got some value, and then the output. Okay, for this one is same, but this one is for 90-degree. So this is the waveform, the sub input, out current, input output, the power value, and then the output. So as mentioned just now, the same process, but because of the firing angle, this shape will be slightly different compared to others. And then the bottom are the same because the firing angle, once increase the firing angle, the time period will be increased. So these are the firing angle for 135. So these are the input current, input output, the power, and then the V out. So the value will be trigger after the firing and the value of gate is supplied. So same goes to over here. This one is 175, and then this will be flow in positive, and then the current value only trigger when the gate will be open. And then here is the same. It will be over here. The input and output will be low, and then the power is the around 600 watt, and then the output until the 25 250 watt. So the same process, it will be the very slow. So 135, and then this one is 175 because it is in the maximum range. So the ripple will be the less and very small compared to others. Same process for this one. The gate will be supplied and then thing. Okay, for the discussion, observe your observations on simulation result and analysis. Okay, in conclusion, able to study and analyze the concept of the single phase full wave AC controller with a resistive load using LTSPI. This is the LTSPI software, and then simulation software to get the output. So the AC voltage from the alternative current source is delivered from an AC voltage controller, which is a convert that controllers the average power voltage, and then there are three controllers actually: average power, voltage, and current. By assuming the firing angle, the RMS output voltage and the output power can be formed in a regular interval. In an electronic switch connected and disconnect the supply and the load, successfully remove the of the source waveform. Before it reaches the load, average output current and voltage difference at voltage to zero, close to zero. The HDHD percentage increase will increase while the power factor decrease. Thank you, madam.